solving engineering exam problems the wrong way, and it's probably costing you time, points, and most devastatingly, your confidence. If you read every exam problem from the first word to the last, and then try to figure out what's going on, this video is for you. Today, I'm going to introduce an effective and universal method for solving engineering exam problems, especially for FE and PE exams. This method works across disciplines, across topics, and under time pressure. I call it the from the end to the beginning method. Let's start with why traditional approach fails. Most exam problems, they are written to overwhelm you. Long problem statement, extra information, distracting context. If you start by carefully reading every sentence from the beginning, your brain gets overloaded before you even know what you are solving for. On timed exam, this is a big mistake. The goal is not to understand the story. The goal is to solve engineering problem efficiently and correctly. Here is the key idea. Do not start at the beginning of the problem. Start at the end. Especially start with the question. Every exam problem, no matter how long it is, it has a very clear ending. That ending tells you exactly what exam writers want from you. This is where your thinking should start. Let me walk you through the method step by step. Step number 1. Read the question only. Ignore the long problem statement for now. Go straight to the last line. Ask yourself, what is being asked here? Is it flow rate? Is it velocity, depth, head loss, or slope? In this example problem, the last line of the problem says, determine the flow rate conveyed by the channel. And that tells us immediately the target variable is flow rate, Q. Let's underline and mentally lock in the target variable. Step number 2, identify keywords. Look for keywords in the question such as calculate, determine, estimate, at uniform flow, under steady state conditions. These keywords immediately narrow down the type of equations we need. Sometimes you need to quickly browse through the statement to get a better idea. Here we can take a quick look and highlight a couple of keywords in the statement, which include open channel, steady uniform flow conditions, and determine the flow rate. Now step number 3, identify the governing equation. Once you know what you are solving for, ask yourself, what is the most relevant equation that contains these variables? At this stage, you are not solving anything yet. You are just choosing the equation. But this step alone eliminates guesswork. So back to the example problem, based on the highlighted keywords, we are trying to determine the flow rate in an open channel under steady uniform flow conditions. So what comes to your mind? Manning's equation is the obvious choice. So step number 4, identify what is given and what is missing in that equation. Now, and only now, we're going to go back to the problem statement. From the equation we selected, let's identify what parameters are given and which parameters are not given. And this is critical. Many students panic when something is not given, but experienced exam solvers see this as a signal, not a problem. From the equation we need Manning's roughness N, cross-sectional area A, hydraulic radius R, slope of energy grade line S. Now as we scan the problem statement, we're going to go through it with purpose. As we read the statement this time, we can find Manning's roughness N equals to 0.013, slope of the channel, which is the same as the slope of energy grade line for steady uniform flow, S equals to 0.0015. A and R, both of them, they are not given directly, but that's not a problem. It simply means we are going to compute them from geometry. Step number 5. Work backwards to find missing parameters. For parameters that are not given, let's ask, how are these typically obtained? Is there another equation that we can use? Is there a chart that we can use? Is there a table that we can refer to? Is there a graph that we can find somewhere? And this is where the method earns the name, from the end to the beginning. Going back to the example problem, we can use the horizontal length and the vertical length ratio 2:1 to find the horizontal length, 2.4. From there, we can calculate the cross-section area, 5.88, and the weighted parameter, 7.87. Lastly, we can calculate the hydraulic radius, 0.75. So, number 6, solve the problem forward. You have now gone from the end of the problem back to the beginning, logically and efficiently. Now that all parameters are identified, and you are going to substitute these values into Manning's equation to solve for the flow rate Q. No confusion, no unnecessary readings, no wasted time. So here we go. We have Manning's coefficient 0.013, slope of the energy grade line 0.0015, cross-sectional area of the flow 5.88, and hydraulic radius 0.75. The flow rate conveyed by the channel is therefore calculated to be approximately 25.5 cubic feet per second. So let's talk about why this method works during your exam. This method works because it mirrors how equations are structured. It minimizes cognitive overload. It prevents you from solving the wrong problem. It also scales well under time pressure. And most importantly, it is repeatable. You can use the same approach for hydraulics, hydrology, structural analysis, environmental engineering, transportation problems. Anywhere equations exist, this method applies. So if you take one thing away from this video, let it be, stop reading problems from the beginning and start solving them from the end. If you want more videos like this, focus on how engineers actually think on exams. Please like this video, subscribe to the channel, and comment below which topics you would like me to cover in future videos. I'll see you in the next one.